So let's start with the new chapter, IoT platforms and design methodology. So just let me quickly uh, tell you what are the topics we are going to cover, uh, and after that I will share the slide. Uh, so here we are going to discuss about IoT platform and design methodology. So under that we are going to study purpose and requirement of your project, then the process, that is process specifications. Then we are going to study domain model specification. We will see what is domain model specification, then what is information model specification. Then we are going to study service specifications. Then there are different IoT level specifications, so that we are going to study. Then there is a functional view specification, operational view specification, then device and component integration, and some application development. Okay. So these are the content which are going to study in the third chapter. So now I will share the PPT. This is the chapter IoT design methodology. For that I am referring Harshdeep Baga textbook. The name is Internet of Things, a hands-on approach. This is the site I referred previously, but now there is no content present there, but I kept it as it is. Uh, but right now for timing, don't go with this website. So these are the outlines, that is for IoT design methodology. It includes purpose and requirement specification, process specification, domain model specification, information model specification, service specification, IoT level specifications, functional view and operational view specification, device and component integration, and lastly application development. So let's start with the IoT design methodology. So these are total 10 steps. We are starting with purpose and requirement. So purpose and requirement basically speaks as a definition, purpose and requirement of IoT design systems. Then there is a process model specification. It defines the use cases. So we are going to study what are the use cases. Then third step is once use cases is defined, the next step is define model specification. Under define model specification, we are going to study defines physical entities, virtual entities, different types of devices, resources, and services in the IoT system. So it means you can say domain model specification. Under that, we are going to study all the components, that is hardware and software platform. Then there is an information model specification. Under that, it defines the structure, that is relation and attributes of all the information in the IoT. Next is a service specification. This service specification nothing but the map process and information model to services and define service specifications. Then next is the IoT level specification. IoT level specification, there are total 9 IoT levels. So it defines the IoT level for the design system. The next is a functional view specification. It is a map IoT level to functional groups. Next is a functional view specification. It is a map level IoT level to functional groups. Then operational view. It is defined communication options, service hosting options, storage option, and device options. So it defines the communication options, various communication options, then storage options, devices options, and so on. The second last step is device and component integration. It has integrated devices, develop and integrate the components. And the last is the develop application for application development. So now we are going to study all the steps in detail. So out of 10 steps, first step is purpose and requirement specification. So this is the first step in IoT system design methodology, is to define the purpose and requirement of the system. In this system, the system purpose, behavior and requirement, that is such as data collection requirement, data analysis requirement, system management requirement, data privacy, security requirements, user interface requirements, all these are captured. So whenever we are starting with the IoT system design, okay, the first step is we need to identify the purpose and requirement specifications of that device or system device. Okay, so it tells about data collection requirements, data analysis requirements, system management requirement, data privacy and security requirement. Yes. Anybody saying something? So this is very important to understand. IoT is all about gathering the information, then analysis of the data, then system management requirement is very important. Data privacy is important, then data security is important, and then user interface requirement for accessing the application. Okay. So all these things are taken care in the first step, that is purpose and requirement specification is very important. So once all the data is getting captured, the next is the process specification. And this is the second step in the IoT design methodology. And it is defined the process specification. In this step, the use cases of the IoT systems are formally described based on and derived from the purpose and requirement specification. So in this step, what is happening? Different use cases on the IoT systems are formally described based on and derived from the purpose and requirement specifications. So different use cases are discussed for the particular application. The next is a domain model specification. This is the third step in the IoT design methodology, and it is defined the domain model. The domain model describes the main concepts, entities, and the object in the domain of the IoT system to be designed. So this is very important. That is, domain model describes the main concept, entities, and the object of the domain of IoT system to be designed. So can you give me example of the entities and the object of any application? What do you understand by this meaning? Entities. What it is saying? It is the domain model describes the main concepts, entities, and object in the domain of the IoT system to be designed. So let's take an example of healthcare system. So when we talk about entities involved for the application of the healthcare, smart healthcare system or a remote healthcare system, what are the entities will be present into that? That is, doctor will be present, then caretaker will be there, patient is there, then relative is there. Okay, so these are the entity in your domain model specification which you will use for drawing your use cases. Okay, and object in the domain of IoT system to be designed. Then domain model defines the attributes of the object and the relationship between the object. Okay, so it clearly defines the relation between the attributes of the object and the relation between the object. Then domain model provides an abstract representation of the concept, object, and entities in the IoT domain, independent of any specific technology or platform. Okay, so initially it has nothing to do with the any technology or platform. Okay, so depending upon the application, these entities are defined first. Then, with the domain model, the IoT system designers can get an understanding of the IoT domain for which the system is to be designed. Next is information model specification. After domain model specification, next step is a fourth step, that is information model specification. It is define the information model. So information model defines the structure of all the information in the IoT system. For example, attributes of virtual entities, relations, etc. Information model does not describe the specifies specific of how the information is represented or stored. So it's simply information model. For example, uh, attributes of the virtual entities and relation it defines. uh, then to define the information model, we first list the virtual entities defined in the domain model. Then information model adds more detail in the virtual entities by defining their attributes and the relation. Fifth step, service specification. This is the fifth step. Service specification defines the services in the IoT system: service type, service input and output, service endpoint, service schedule, service preconditions, and service efforts. So all service related information is gathered in this system, in this step, that is service specification. So what are the types of service specification? Such as IoT system, service in the IoT system, different types of services, service input and output, that is integration at the input side and integration at the output side, that is your device to cloud and cloud to device interface, and they're accessing the data, that is called as a service input and output. Then service endpoints, service scheduling is also a very important factor, service preconditions, and service effects. So nowadays there is a cloud system available to provide all this type of services to the user. So it is inbuilt in the cloud platform, and by paying or subscribing to particular services, we can able to access the services from the cloud. Next is IoT level specification. This is the sixth step, and it is defined. IoT level specification. Yes, we have studied 6 IoT level specification along with the example. Okay, in chapter 1. So these are the same IoT level specification. So these are 5, right? 5 IoT level specification we have studied. So we have studied that IoT level specifications as, first of all, there is a device, and then there is a end user, and in between there is a cloud system. Okay, so this architecture is a level 1 architecture where only monitoring is possible. Then it includes the interface. Okay, and gradually it adds the interfaces, and there are total 5 levels from IoT 1 to IoT 5, and based on the application. Then step 7, that is the functional view specification. The functional view specification defines the functions of the IoT system grouped in various functional groups. Each functional group either provides functionalities for interacting with instances of concepts defined in the domain model, or provides information related to the concepts. Then operational view specification. It is the 8th step, and in this step various options pertaining to the IoT system deployment and operations are defined, such as service hosting options, storage operation, storage options, device options, application hosting options, and so on. The second last step of design methodology is device and component integration. So IoT design methodology is the integration of the device and components. So we know that various devices are integrated, that is hardware, then sensors, then controller, then cloud platform is there, then again there is the integration of the mobile, and so on. The last is the application development. The final step in the IoT design methodology is to develop the IoT application. So these are the steps which you need to consider while designing your IoT level system. First of all, you have to think about the purpose and requirement, which will take care about the all the purposes, that is collecting the data, requirement analysis, system management, requirement data policy, security, okay, all these aspects. The next is the process specification. So in the process specification, the describes based on and derived from the purpose and the requirement specification only. Then there is a domain model specification. Once domain model specification is done, then you have to go to the information model specification, which talks about the virtual entities and the relation between the virtual entities. Then there is a service specification. What are the services is required, and uh, service related all the specifications such as service endpoint, precondition, effects, scheduling. All these things are taken care under step 5. Then IoT level specifications, also very important, that we have studied in chapter 1, based on the application and the integration. Then there is a functional view specification for the group and optional view specification. Then there is a device and component integration, that is the hardware interfacing you need to learn, and then develop the device. Okay. These are the 10 methodology steps for IoT design. So let's take a example of home automation case study. So here, let's start with the design design methodology for home automation. So let's start with the purpose and the requirement. So here, applying this to our example of home smart automation system, the purpose and requirement for the system may be described as, first of all, let's see the purpose. Purpose is a home automation system that allows controlling of the light in a home remotely using a web application. So for this particular application, what is the purpose? Home automation system that allows the controlling of the light. Okay, so only one application that they have taken, that is the controlling of the light of the house. Then let's see behavior. Behavior, the home automation system should have auto and manual mode. That is, you can operate it or operate it by both the modes. In auto mode, the system measures the light level in the room and switches on the light when it gets dark. And in manual mode, the system provides the options of manually and remotely switching on and off of the light. So this should be the uh, behavior pattern of your device. Then system management requirement is also important. That is, the system should provide remote monitoring and control functions. Then let's see data analysis requirement. So whatever data you are gathering, that is the system should perform local analysis of the data. Then application development requirement. In application development requirement, the application should be deployed locally onto the device, but stored should be accessible remotely. Okay, these are the requirements for your devices. So here, what is happening? The data is stored in the local storage. And the last is a security requirement. Last is a security requirement. The system should have basic user authentication capability. So this should be your purpose and requirement of the design system. It includes purpose, behavior, system management requirement, data analysis requirement, application development requirement, and security requirement. Okay. So these are the 6 points you need to consider uh, while going for purpose and requirement of the system design. Then process flow, that is nothing but the second step, that is your use case. So here you can see that the example we have taken as a home automation light controlling. So this is the mode. There are 2 modes as you define in the process, that is auto mode and the manual mode. So what is happening in auto mode? Light level is there. Okay, if light level is high, okay, light intensity high in the room, that state of the indication is off. Okay, LED or light should be off. If light intensity in the room is low, then light turn on the light. Okay, so this is in the auto mode. So and in manual mode, light state क्या रहेगा? If state is off, okay, state is off. Okay, and if state is on, then state is on. Okay, so depending upon the, if state is off, so it will off the light. If state is on, it will on the light. Okay, it is manual. Then domain model specification. So here you can see the domain model specification. This diagram is visible to everyone.
Yes, ma'am.
So let's look at the entities. So here type is entity, service, resources, device, and attributes. Okay. Start from interacts with. So here we have a user at the top level application layer. So here you can see the first level, that is the sensor. So sensor will gather the information, that is the change in the light intensity in the room. It is attached to your mini computer. So first of all, we'll start from here, that is the sensing part, gathering the information, light intensity information, and it is sending to the device microcomputer. Then it goes to the on device resources, which it will store locally, and network resources. This goes to the resources. Okay, then we'll do programming over here, and here only there is a actuator connected. So actuator connected to the relay. This relay is given to the physical entity for turning on and off. Then this physical entity is connected to the user for manual mode operation. Then there is a virtual entity appliances. Virtual entity room is also required. Is connected to active digital art face app, that is your server where you want to access your resources, and this is the services. from that server. Okay, and this is human user. Both way it is possible to operate. Manual mode and the this is the manual auto mode and the manual. So this is the domain model specification where each and every block is explained properly, that is type, entity, services, resources, devices and its attributes. Then information model specification. In information model specification, again it has all those content, that is attribution, model and everything. So here we can start with the virtual entity room. So entity type is room and ID is room number 1. Okay. To access the room remotely, we need to create a virtual entity room, and the entity type is room and ID is room number 1. So here attribute is light level. Attribute name is a light level, so we can have different attributes such as light, water indication and so on. So currently use case which we are discussing right now, it is related to light intensity detection and controlling. That attribute type is level 1 or level 2. So here we are defining that attribute type is level. So we are operating in the 2 level only, level high and level low, which indicates the LED or light high or light low. Okay. So virtual entity light appliances, that is at the relay side. So it is appliances, ID is light 1, room ID, room 1. Okay, so here what is happening, once you get the information from attribute 1, that is high and low, based on that, this attribute name is light state. So light level information is used for turning on and off the light state attributes. Okay. The state is on and off, which is connected to the relay set. So this is the information model specification. So again, I'm giving you 2 minutes time. So closely look at this diagram, which is very important to understand. What are the, here you will get the clear idea of what are the attributes and how it is working together. And what is the role of virtual entity. So again, two groups, they have taken the same project. So there you can use this attribute, but then you have to work on the multiple attributes together. Okay, so here only light level is considered. So like that, your diagram will add more attributes into this. Okay. So you need to further modify this diagram. Then service specification. So in service specification, you can see it is an integration of both process specification and information model. You can combine this both. So here we'll start from the process specification, that is mode services, that is auto mode and manual mode. Then there is a state services, set the light appliance state to on and off or retrieves the current light state. Simply you can replace this with your algorithm or process flow of your design, where you will define the role of each and every entities in detail and in the flow. So the controller service, it is in auto mode. The controller service monitors the light level and switches the light on and off and update the status in the status database. In manual mode, the controller device services retrieves the current state from the database and switches the light on and off. So in current database, the state is on, then it switches the light on. If the in current database the state is off, then it switches the light off. Okay? So that is the manual mode. Then service specification. So here we can see there are 3 services, 1, 2 and 3. Let's look at the type of the services. First let's see the name. Name is the state, second service is the controller, and third service is a mode. Type is REST, native and REST. So here first service, that is the REST and store state, has input, state on off, and endpoint will be home, state, and protocol uses is HTTP. So whenever there is an interface between mobile and the cloud, okay, and the information is transmitted, so the basic protocol it is uses the HTTP protocol at the user end, the end side. Okay, and when your data is transferring from sensor to the cloud or sensor to controller in the cloud, there are various protocols are used, which we have studied in the IoT protocol, that is MQTT, SMQTT, and so on. Then there is a service controller. So here we have an input, auto mode and output mode, state on and off. Output is state on and off, and it is scheduled after every 5 seconds. The next is a service mode, that is again it is mode is on set mode is on auto and manual. Then there is an endpoint, home, mode, and again protocol which is uses HTTP protocol, and output is current mode is auto and manual. So this is a service specification. Then this is a IoT level specification, that is we required only one monitoring node. Okay, and performance analysis and data storage data is required. So we required a device, then we required resources, controlling devices. For controlling devices and REST services we required a database. REST communication is required between REST services and the application, and local. So it does not include the cloud. Then again this is the functional view specification. So here there are total 6 specifications. So let's start with the first one. First is a IoT device maps to the device, that is sensors, actuator devices, computing devices. So all the hardware components are gathered here, and management, that is a device management. Okay, so this is the first step. Then second is resources mapped to the device FG on device resources, and communication FG, that is communication APs is and protocols, that is the here we are using HTTP protocol. Third is controller service mapped to the service FG, that is native service, and web services mapped to service FG, that is web services. And web services are mapped to the service FG, that is web services. Then we have a database, it is a local database. So database mapped to the management FG, that is database management, and security, database security. And the last is the application maps to application FG, that is web application and the database services. Okay, and management also, that is app management and security app management. So this is about functional view specification. So we have studied this component detail of IoT technology or IT architecture in chapter 1. So same, that is device, then communication, services, application, management and security. So all components are having a major role to play for any particular application. Then we have a operational view specification. In operational view specification basically deal with the role, that is for actuator there is a relay and switch, sensors are LDR, and computing devices are Raspberry Pi at the device level. So in device level we have two types of devices, sensors and the actuator, and any computing devices such as a controller or a processor. Then the next block is the application management block. Okay, so various applications related to the data computing are listed over here, that is data device management, database management and application management based on its platform. Okay, that is for database management MySQL DB management is used, for device management Raspberry Pi device management is used, and so on. Then there is a native service and web services. It is all done with the controller services, mode rest services, state rest services. Then there is a application. Application again, web app, application server, database server. Okay, so these are the entities present in the application level. Then there is a security, very important, security of the data while transferring and recollecting. So for that, authentication is very important. Authorization of the device is also very important for secure data transmission. Then there is a communication API, which is a REST API, communication protocols, link layer protocols, network layer protocol, transport layer protocol, and application layer protocol. If this needs to be defined and clear for operation view specification. Then once you have finished with the operational view specification, the next step is device and component integration. So first of all, what you have to do is in device and component integration, you have to list down all the hardware components and its specification, that is pin diagram, power requirement, everything. Okay, and then one by one you start interfacing your devices, connecting all the devices with each other. That is device and component integration. That is step number 9. And then troubleshoot. And once you have done that simulation part, okay, and troubleshooting part, now just check your expected output. That is application development is what? In this case, it is auto and light. So auto, the control light appliances automatically based on the lightning condition in the room. And light is, this is auto, and if you click here, it will be manual mode. This is the dashboard. And light is when the example is when this is in auto mode, it is used for manual controlling the light appliances. When auto mode is on, it reflects the current state of the light appliances as per the block diagram. So this is the implementation RESTful web services. The same diagram which I have explained, that is first step is map services model, field store storage, that is for on and off. Then write model serializers, that is serialize allow complex data such as model instances to be converted to native Python data type that can then be easily rendered into different types of languages, JSON, XML, or other content types. This is the program related to the web interface of your devices for your application, RESTful web services. And this is the implementation controller native services diagram program. Here it is used in embedded C language. And then it is an implementation part. Code along with the user interface. So finally, integrated device system is device, resource, controller device, database, REST services, app, okay, local, and these are the platforms which it operates on. That is set up the device, deploy and run the REST and native services, deploy and run the application, set up the database. This is about controlling the light action in home automation. So this way you have to work for your mini project also. You have to consider all these 10 steps while designing your IoT system. These are the 10 systems. Anybody is having any doubt? Can ask. Meanwhile, I'll take the attendance. Answer roll call. Rule number 1. Rule number 1. Present. Rule number 2.
Present, ma'am.
Just a second. Rule number 2 is present. Rule number 3. Vibha,
Present, ma'am. Yes, ma'am. Present, ma'am.
Neha, Akanksha, Pratiksha, Siddhi, Aditya,
Present, ma'am.
Rinkita,
Present, ma'am.
Rohan, Shraddha,
Present, ma'am.
Priyanka,
Present, ma'am.
Saurabh,
Present, ma'am.
Prajwal,
Present, ma'am.
Omkar,
Present, ma'am.
Sonal,
Present, ma'am.
Shivam, Chirag, Kedar, Rucha,
Present, ma'am.
Bhaskar, Ejaz, Neha,
Present, ma'am.
Rahul, sorry, Ameya, is absent, Rahul,
Yes, ma'am.
Neha, Rishikesh,
Present, ma'am.
Ravi,
Present, ma'am.
Shubham, Pranav, Gaurav,
Present, ma'am. Gaurav present.
Devnathan, yes, Devnathan,
Present, ma'am. Present, ma'am.
Rohit, Rutuja, Vikas, Vishal,
Yes, ma'am.
Neha,
Present, ma'am.
Paras,
Present, ma'am.
Karthik, Sandhya,
Present, ma'am.
Shashank,
Present, ma'am.
Aparna,
Present, ma'am.
Pawan,
Present, ma'am.
Pratik, Rohan, Shubham, Devashri,
Present, ma'am.
Pratik,
Present, ma'am.
Sagar,
Present, ma'am.
Akshay,
Present, ma'am.
Poonam,
Present, ma'am.
Saurabh, Nilesh, Omkar,
Present, ma'am.
Shweta, Saurabh,
Present, ma'am.
Sanjay,
Present, ma'am.
sorry, Kajal, Priyanka,
Present, ma'am.
Archon, Hemant,
Present, ma'am.
Okay, so for A3 batch, I have organized, I have scheduled a meeting, that is mentor meeting at 12:20. Okay, 12:20. So I'll update the link in the group. So you have to join compulsory all A3 students for mentor meeting 1. Okay. So see you A3 batch. See you at 12:20. Now you can leave. Thank you.